Hi, my name's Brett Allison. I'm a performance consultant and director of technical services at IntelliMagic. Today I'm going to talk about a better way to buy, implement, and manage the performance of disk storage for SAN and Mainframe. What are the IntelliMagic Availability Intelligence solutions? Well, IntelliMagic Vision is our flagship product. It comes in several flavors for different product support. It comes in ZOS, ZOS Disk, ZOS Tape, and SAN flavors, and its goal is to protect availability and avoid performance problems with automated visibility inside your storage infrastructure. IntelliMagic Direction is designed to model the performance of your workloads on specific storage hardware configurations. The objectives for today are to make sure there's an understanding of what availability intelligence is. We'll also talk about storage performance modeling concepts and how they apply to storage management. And then we'll talk about the storage management lifecycle and capacity management, how that builds and plays into the design phase, where I'll provide some examples of design failures, some challenges that are ever present in storage architecture, and best practices for storage architecture. And then we'll go on to talk about the last two phases of the lifecycle, which are the build and the run phase. What is availability intelligence? Well, availability as defined by ITIL is the ability of a configuration item or IT service to perform its agreed function when required. Intelligence, as defined by Sun Tzu, is foreknowledge of an adversary. So what makes this powerful is when you combine the two, availability intelligence, which is the automated analysis of performance and configuration data using built-in knowledge about the hardware. What this does is it generates foresight, which allow you to protect availability. In this slide, we'll talk briefly about storage performance modeling concepts. Essentially, the goal of storage performance modeling is to solve the following equation. Configuration information plus workload information equals performance. The following picture is an abstraction of the configuration of a disk storage system. On the front end, you have host adapters, or in some cases called directors. Within the controller, you also have processor resources as well as cache resources. On the back end, you have a device adapter or a disk adapter, or sometimes referred to as a disk director. And then on the back end, you have the connected disk drives. An I/O workload consists of the following categories: reads, which can be broken down into random reads or sequential reads, random read hits or random read misses. On the other side, we have writes, which can be random or sequential, and the random writes can be random hit, meaning the record that's being updated is already in cache, or a random miss, which means the record that is being updated or the track that's being updated is not in cache. Sequential operations have the effect of cache hits because the controllers can do prefetching and read the data into cache before it's required. So these operations tend to have a lower response time than the random operations and require less disk operations. IntelliMagic Direction, under the covers, is a series of queues and workload input. There are several sections in this diagram. The yellow section represents workload input. The blue sections are the internal components, and the green represents the outputs. To put it simply, the workload comes into the queuing model. There are adapter models, queue time spent at each adapter, and service times spent at each adapter. There are processor models. These are things like the Intel processors or customized ASICs or RISC processors that are embedded into the controllers. These have both a cost for the service time and queue time associated with them. And the drive models, these are things like the speed of the drives influence these, the RPMs would influence these, the seek time. So each of the drive models is a reflection of the drive specifications and capabilities. Ideally, the models are built based on specifications from vendors as well as measured data from workloads in the wild.
This is just a brief overview of what we will be discussing in the actual video. If you would like more detailed explanations, as well as more content, please follow the link in the annotation.